Picture this: magic at your fingertips, right on your phone. YouTube Shorts has turned real-time AI-powered video effects into everyday reality. It sounds like science fiction, but it's here now. But here's the twist. Bringing advanced, gigantic generative AI models down to the scale of a smartphone without sacrificing instant responsiveness is anything but straightforward. So, how did YouTube's team pull off this technical feat? Let's peel back the curtain on the tech-powering real-time generative AI effects on YouTube Shorts, from the mega-sized models fueling cartoon transformations to the tiny, mobile-optimized versions that run in your pocket. Along the way, we'll uncover pitfalls, clever solutions, and at least one debate that might surprise you. It all starts with smart data choices. Great AI features aren't magic. They're built on meticulously curated data. In YouTube's case, the journey began with assembling a robust and ethically sourced dataset of faces. The team didn't stop at quantity or simple diversity. They were deliberate in covering a wide spectrum of ages, genders, and this is crucial, skin tones, measured carefully using the Monk skin tone scale. That step is essential for fairness and for effects to perform consistently across everyone, not just a subset of users. And this is the part most people miss. Data diversity isn't just a checkbox for social good. It's also non-negotiable for technical consistency. Would you have guessed that algorithmic fairness is so entwined with the user experience? From brainy giants to mobile-sized wizards, the teacher-student technique. At the heart of YouTube's solution is a clever learning trick called knowledge distillation, sometimes called the teacher-student method. Here's how it works. Imagine a world-class artist, the teacher, with an encyclopedic command of visual style and transformation, but who paints at a snail's pace. Impressive, but you can't have slowdowns when creators want instant results. Early on, YouTube's team relied on heavy-duty models like StyleGAN 2 and tools such as Style Clip to experiment with facial transformations. As their ambitions grew, they adopted newer, more capable models, such as Google DeepMind's Imagen, for richer styles and more precise effects. But for day-to-day magic, you need a prodigy who's quick, agile, and focused. Enter the student. A compact model based on a U-Net architecture known to shine in image transformation tasks, efficiently encoded with a MobileNet backbone. This makes it both fast and lean enough to operate directly on consumer devices, even those with modest hardware. How do you shrink the genius? The art of distillation. Training the student model isn't as simple as copying notes from the teacher. Purely synthetic training data can be problematic. It often creates weird glitches or results in loss of fine detail. To get reliable production-quality effects, YouTube's engineers combined real-world data with carefully constructed before and after image pairs. They ramped up the realism by including various augmentations, think AR sunglasses, synthetic hands for occlusion, and more, to really stress-test the model. To match the teacher's artistry, students are trained using a blend of loss functions. L1 for pixel-level accuracy, LPIPS, which measures perceptual realism, adaptive, and adversarial losses to chase realism and variety. Add to this a continuous neural architecture search where model parameters are fine-tuned for specific creative tasks and device types. Ever wondered how your budget phone keeps up with AI wizardry? This is one big reason: preserving you in every frame. The inversion challenge. Here's something you may not have realized. AI doesn't just slap an effect on your photo. It rebuilds the image in its mind, translating your features into a compressed mathematical form called the latent space. But here's where it gets controversial. A generic approach often fails to keep the real you intact. Classic inversion methods sometimes shift skin tones, erase glasses, or worse, subtly morph your identity entirely. That's a problem. Are you okay with even playful filters tweaking who you are at a core level? To tackle this, YouTube uses pivotal tuning inversion, PTI, an iterative process that fine-tunes the generator to your unique facial features. First, your image is encoded into an embedding, essentially a digital signature. This goes through several rounds of tuning so that when the effect is added, say, via a style clip-generated transformation, it's still recognizably you, only with the creative twist you wanted. If it sounds like personal tailoring for your digital face, that's because it is. How does this all run in your hand? Meet MediaPipe. Making these effects work in real time on a mobile device demands more than just efficient AI models. The workflow unfolds like this. 1. MediaPipe face mesh pinpoints faces in the video feed. 2. The system carefully crops and orients the face so the student model receives clean, consistent input. 3. The processed image is dropped into the student model, which applies the effect in milliseconds. 4. The transformed face is blended back into the live video, frame by frame, with a responsiveness that must hit at least 30 frames per second. That's under 33 milliseconds per frame. On flagship phones, this pipeline is blazing fast, about 6 milliseconds per frame on Google's Pixel 8 Pro and around 10.6 milliseconds on an iPhone 13's GPU. And the team has spent substantial effort optimizing for less powerful devices, broadening access to creators across the globe. What's the real impact? Unleashing everyone's creativity. Since its rollout in 2023, this technology has powered some of YouTube Shorts' most beloved features. From zany, expression-triggered effects like Never Blink, to thematic Halloween masks, to sweeping, full-frame cartoon overlays like Toon 2. Thanks to these innovations, creators of all stripes can unlock new possibilities right from their phone. But here comes a big, lingering question. Are we comfortable with ever more advanced generative AI transforming our appearance, not just for fun, but perhaps in ways we can't always anticipate? Are you excited about ultra-realistic AI-crafted video effects, or is there a line where digital makeovers go too far? This is only the start. YouTube's AI team is moving toward even faster and more capable models like Veo 3, aiming to shrink latency further for every device, not just the flagship phones. Imagine the future of Shorts, with even bolder effects. What would you want to see, or avoid? Where should the boundaries be drawn? Let's hear your perspectives below. Do these creative tools empower self-expression, or do they risk blurring the lines of authenticity? Where do you stand on the AI-enabled makeover revolution?